Guys, what's up? Um, I am going to be working through today a problem that has to do with angle of depression and angle of elevation. This is meant to be similar to what you have in your homework, but it is a little bit different. We've got a hot air balloon 700 feet up in the air. A person in the balloon needs to look down with an angle of depression of 40 degrees to see one house and an angle of depression of 28 degrees to see another house. If you think about it, you should be able to realize that the angle of depression of 40 degrees means that that house is closer, whereas the angle of depression of 28 degrees means that that house is further away. But because a diagram is not provided here, we're definitely going to make one. So here we go. We've got the hot air balloon up here, the person in the hot air balloon, hey, and they are 700 feet above the ground. There's not really a reason for that line right there. So let's see, this will be 700 feet. And I know that compared to horizontal, this is what an angle of depression means. It's compared to horizontal. So this person has to look down with an angle of 40 degrees to see one house and down with an angle of 28 degrees to see another house. And here's the thing. We aren't given a lot of other information here. So it doesn't seem like we've got a whole ton to work with. But what we can do is actually draw not one, but two right triangles. So I'm going to use the fact that this right here is 700, that that's a right angle. And then I'm going to draw two separate triangles to show each one of the situations. I'm going to scroll down to do this, give myself some room, and I'm going to redraw with the two triangles. Tell you what, I'll actually scroll down so as to obscure the problem, give myself as much space as possible. This right here, now the rookie move would be to label this 40 degrees. But remember, this is the 40 degrees. So think about it. What would the other one be that's right next to it? Well, when you put them together, they have to make 90. So this one is 50 degrees. Now the other triangle had a 28-degree angle of depression. That's up here. Well, guess what? What's the other one going to be that's next to it? That's right. It's going to be 90 take away 28. Well, 90 take away 20 is 70. Take away 8 is 62. So here you've got a 62-degree angle. They're both right triangles. And here is the secret sauce. Each one of these triangles has the same height, the same length on the left-hand side. It's 700 in this one and 700 in this one. So now what we're going to do is set up a system of equations that actually describes these. Think quickly about the fact that this is meant to show one here and one here. So if we look at this distance as being a certain amount, so this is x and this is y, then we can describe these two distances in terms of those two variables. Remember that the one that has the lower, the smaller angle of depression, that's this guy right here on the right, this is going to be those two distances combined. So this will be x plus y. Whereas the one where the person has to look down at a larger angle of depression, they have to look down further, this one is closer to the balloon. So this one will actually just be y. Okay, now I've got a situation that's ready to be turned into equations, and I can stop worrying about modeling and start worrying about equations and solving those equations. So equation 1 will come from triangle number 1. What have I got here? I've got that the 50-degree angle is right here. I've got that the y is opposite and the 700 is adjacent. Think about the trig ratio that uses opposite and adjacent. SOHCAHTOA, T-O-A that means that you're going to be using tangent in this problem. Not that one. There we go. So the tangent of 50 degrees is going to be equal to the opposite, which is y, over the adjacent, which is 700. The second equation is going to be based on this triangle. In this case, the tangent of 62 degrees has to be equal to, again, opposite over adjacent. That's x plus y over 700. Now that it's in the form of a system of equations, it's not that difficult to solve it. It's just some tough algebra. So let's go through it, but it'll be fast. What we're interested in is the value of x, because that shows how far apart the houses are, which is what we were interested in. In the interest of solving for x, I'm going to isolate y in the first equation and put that into the second equation, at which point x should become the only variable. So y will be 700 times the tangent of 50 degrees. And then when I put that into here, this y can become 700 tangent of 50 degrees. So tangent of 62 equals x plus, well, it used to be x plus y, right? But now it's going to be x plus 700 tan 50. And that, ooh, nice big fraction bar, all over 700. All that's left for me to do is to isolate the x. So now I'm going to take this equation. I'm going to times it by 700 on each side. So 700 tan 62. Sometimes I write the degree symbol, sometimes not. Equals x plus 700 tan 50. And all that I have to do is subtract. So x equals 700 tangent of 62 minus 700 tan 50. And this, boys and girls, is why God made calculators. So 700 tangent of 62 minus 700 tangent of 50. And I get 482.28. 480, well, we're really, I mean, for large numbers, you don't worry too much about decimals. That's probably fine. So 482, and the height, the only length that was given here was in feet. It was from top to bottom, it was 700 feet, so all other lengths must be in feet. So in order to have these differences in angles, the two houses must be 482 feet apart. If you like this video, if you'd like to set up some tutoring sessions so we can go over your homework, give me a call at 617-966-3198, or you can also visit me online at sntutoring.com, and we can set up some sessions. See you later.